Hello, fellow Mavericks, and welcome to the 23rd Sequence Show with Crystal and Tyreek. Today we will help you classify sequences and find the expression to any term in a sequence. To start off, in order to classify a given sequence as arithmetic, geometric, or neither, you have to find a pattern or relationship between the numbers in a sequence.
You can identify an arithmetic sequence because there's a common difference or constant change through addition or subtraction. For example,
can you see a constant change in this sequence?
yes. What is it? -2.
Correct. To get to each term, you subtract 2 from the first term. Now let's move on to geometric sequences.
We can identify geometric sequences through the common ratio, where you find through multiplication or division. Can you identify the common ratio in this sequence? Remember, you have to use multiplication or division.
Multiply by 1/4.
Correct. You get to the following term by multiplying by 1/4.
If you cannot identify constant change or common difference through either multiplication, division, subtraction, or addition, then the sequence is classified as neither arithmetic or geometric. For example,
This sequence obviously does not follow a pattern, so it will be neither arithmetic or geometric. Here are some sequences. Classify them as arithmetic, geometric, or neither.
Irving, which is this sequence arithmetic, geometric, or neither?
This sequence is geometric.
Yes, because to get to each term, you multiply by 3. Samuel, is this sequence arithmetic, geometric, or neither?
That one is neither.
Yes, because obviously there's no difference. Samuel and Irving, is this sequence geometric, arithmetic, or neither?
The sequence is arithmetic.
Yes, because to get to each term, you subtract how much, Samuel?
You subtract 10.
Yes.
Good job.
And now, time for the fun part, finding the expressions used to generate the terms of a sequence. Yay.
For any given sequence, like this one, 23, 21, 19, 17, and so on, the first term is A1. The second is A2, the third A3, and so on. The next term in the sequence will be AN.
N stands for any number.
What if you were asked what the 23rd term of the sequence would be? Would you subtract the common difference 23 times? Or is there an easier way to find the 23rd term? Well, there is, and we're here to tell you that.
Yes, we are.
In general, an arithmetic sequence looks like with D being the common difference or constant change. Generally, AN in an arithmetic sequence is found with this expression, A1 plus N minus 1 times D, with N being the term number
and D being the common difference or constant change.
Find the 23rd term of the sequence using this expression.
Irvin, what's the answer?
Negative 21.
Correct. The answer would be negative 21 because when you plug in the numbers, 23 for A1 plus 23 for N, because we're looking for the 23rd term, minus 1 times D is negative 2. That all equals negative 21.
Move on to finding the expression, the general expression for geometric sequence. The general expression is
A1 times R.
times R.
The next one is A1 times R squared. The next one is A1 times R cubed.
And so on.
R would be the common ratio between the numbers. In general, A1 equals
A1 times R N minus 1. This represents the common ratio. This represents the term numbers that you're looking for. This and this. This and this should be the same. Now, can you find the 7th term in the following sequence? 64, 16, 4, 1, and 1/4.
Samuel, what's the answer?
I believe the answer is 1 divided by 64.
Correct. And we get that by plugging in our numbers into the expression.
Yes.
A7 will equal A1, which is 64, times the common ratio, which is 1/4, N minus 1. And that equals 1 over 64.
Now that you know the general expressions to generate the terms in either arithmetic or geometric sequences, find the 13th term of any two of these 5 sequences. But first you need to know if the sequence is geometric or arithmetic, or neither. Good luck.
Let's work out problem A together. First, we can see that the sequence is what, Irvin?
Geometric.
Correct. And the common ratio is, Sam?
5.
Good. Now let's plug this into general expression, which is AN equals A1 times RN minus 1. We're looking for the 13th term, so it'll be A13, A1, which is 5, times R, which is 5, 13 minus 1. And that all equals this really big number. That's all we have for today. Thank you for tuning to the 23rd Sequence Show. Bye.